So let's try to apply this one here. So for the first one, it's multiplication, 4.56 times 2.705. It could be any quantity, okay? So first things first is try to identify the number of significant digits. So for the first number, you have 3 significant figures. The other one is 4 significant figures. So when you try to multiply this one up, you try to write the answer first, everything, 12.3348. If you're gonna write the product, whole product, the whole product will give you a total of 6 significant figures. However, since you are multiplying, you need to follow the lowest number, so which is 3. So therefore, you will only record up to 3. So not 3 decimal place, okay? But 3 significant digits. And the 3 significant digits, obviously, you're going to start from left value to the right. That means that here you have tens, ones, and then you have tenths. So you're going to cut off up to 3. So 3, this is where you apply your rounding off numbers. So you're going to round it off up to tenths here. So the general rule is that if the number after that is 5 or greater than 5, we're gonna round up. But if not, round down. So in this case, after, again, we cut off up to tenths, because tenths gives me 3 significant figures. So now I'll be rounding off up to tenths of something. It could be tenths of a centimeter, tenths of a kilogram, or tenths of a second. So since after that is 3, so instead of 12.33, I will place 12.3. So that's my final answer. My final answer should follow the least number of significant figures. Okay? And then the next example is division. So just do this one in your calculator. But again, I told you that take note of the number of significant figures. The first one has 3 significant figures. And then this one here has 2 significant figures. So therefore, my final answer should take the 2 significant figures. But I will try to divide that one first. 1.98 divided by 0.45. The answer is, well, actually also in 2 significant digits, which is 4.4. So I'm going to stop. My final answer should have 2 significant figures, okay? Because I'm dividing, again, division and multiplication follow the same rule, okay? However, if you're adding and subtracting, you have to count the lowest. Actually, you're going to base it from the precision of your measurement. So the precision, again, can be seen from the number of decimal places in your number. So that means that 3.15 here, for the last number here is your doubtful figure. So you're using a particular instrument, maybe they can read up to tenths of something. It could be, again, this could represent any quantities here. But if you're adding the two, the reason for that is the final measurement, if this is a measurement or something, the final measurement will not be more accurate compared to the least precise instrument that you're using. So in this case, you have 3 significant figures. Again, its precision is only up to tenths of something. But this one here, this is more precise measurement in the sense that you have more decimal places. That means that it can read up to tens, hundred, thousands of something. It could be thousands of a centimeter. So for sure, this is not an if you're talking about a ruler, so this could not be an ordinary ruler. You have 2, 4, 5 significant figures. However, if you are adding or subtracting, you're just cutting off. So therefore, you just have to cut off up to here. Oops. Yeah. You just have to take note of up to here. That means that when you try to add, well, try to add all the values. That's 4. That's 1, 0, 1, carry 1, 1, 2. That's 6. Decimal place will not change. That would be 5. Okay. So the final answer is not 5.6014, but the final answer should be written up to hundreds. So that should be 5.60. So it's not up to the number of significant digits, okay? Again, for addition and subtraction, you try to cut off to the to the least precise measurement. Again, the number of decimal places. And for subtraction, same thing. If I'm gonna subtract this one manually, this is then so 9. This should be 8 point, and then this should be 5, and then 2. So if you're gonna subtract that one, your calculator will give you 25.89. However, again, you're subtracting, so you follow the rule. The second rule, which is to cut off to the least number of decimal place. And you have only to express this one up to 1 decimal place. So therefore, you're going to cut off up to here. So you're going to record this one as 25 point. Well, after 8 is 9. That is greater or equal to 5, greater than 5. So therefore, you're going to round up. So the final answer is 25.9. Okay. So how about dealing with scientific notation here? Well, actually, you can just try. It follows the same rule. Okay. So you need to count the number of significant digits. Again, the number of significant digits in your scientific notation is only based from the value of m. So you will not mind about this. You mind about the value of m. So this one here, 3.0, that's 2 significant figures. And then this one here, 2.78, is 3 significant figures also. So if you're going to multiply this in your calculator, like, anyway, your calculator has an option of to express it in scientific notation. It will give you, maybe some calculators will give you the value itself, 834. But that's not your final answer, because you need to express this one to 2 significant figures, because this is multiplication. So that means that I should express my final answer only up to 2 significant digits, which is up to here. So if I'm gonna record this one, it should be, again, in our case, the zeros are insignificant. So therefore, I can write that one as 830. It could be any unit. Or, again, just to specify the number of significant digits, I can also write this in scientific notation form as 8.3 times 10 to the power of 2. Okay? So both answers are okay, because both answers have 2 significant digits. Again, this has 2 significant figures. I keep saying digits, but anyway, some books uses significant digits, some books uses significant figures, but yeah. Okay, and then lastly here, you have 0.0050. So again, you have 0, but this is a different case with 710 earlier. You have decimal in front here. And after a non-zero, the 0 here is considered as significant. So therefore, the first number has 2 significant figures. This one has 3. And if you're going to divide the 2, it will actually give you 0.000157 But then again, my final answer should contain 2 significant figures. And again, the 2 significant figures from my answer is only up to the 5. So if I'm going to write this one in correct number of significant figures, I can write that one as 0.00016. Again, it's 6 because after where I'm going to cut off is greater or equal to 5. 7 is greater or equal to 5. Or if you want to answer them in scientific notation, that is 1.6 times 10 to the power of -4. So both cases gives you 2 significant figures, which is what I want. Again, the final answer is in 2 significant figures. So most formula in physics are multiplication or division. So therefore, might as well familiarize this one. Maybe in some cases or at the start, be more considerate first. But as we move forward, just remember this particular rule. So you just have to, you don't have to randomly round off your answer. You're going to base it with these rules here. It's either addition or subtraction or multiplication or division. You try to follow this rule, because the numbers that we're dealing in physics are quantities, and these quantities represent something, measurement, or measurement of a particular quantity. Okay, so try to remember that.